asking for the order, and then there is no mark on the order. Yeah.
I checked the old video.
Okay. This looks okay.
You should be with the picture.
I didn't cheat. He told us if you're confused, you can check.
Yeah, exactly. Rather than just sitting there looking stupid, you know?
Yesterday I gave the chemistry test and I got 0. Already, although I have done I have done right 7 questions, but like if it's trigonal, I have it's T is capital. I have written T capital, and in the answer it's T is not capital.
T capital in the
It was not right.
I got
Almost.
10.
I had one wrong because
After
of
Lorraine.
typo. And I had another one wrong because I was wrong.
I have right.
I have 4 wrong and 6
One wrong
right.
because of spelling, one wrong because of spelling.
No, I'll talk to Lorraine.
It's fine, it's just
It's
the way it's
alright,
made.
man.
And
Yeah, chill. Alright.
There.
Let's have a look now at the collisions homework. Physics, mechanics, and then we have where are we? We are collisions here. Let's have a look at what the homework was.
Are we gonna get the questions on the exam?
Physics?
Yes.
What do you mean? You'll have a test after the break.
No.
After
That
the
day
break
you
is
said,
nice.
like last week, we might have a test.
Ah, yeah,
We
changed my
will
mind.
return.
Change my mind. Yeah. No, trust me. No. Okay.
Maybe like we can only Wednesday we can do it to Friday.
But then I'll have to make them. Then I'll have to make them. And this is really the key reason for changing my mind.
Fair enough.
Yes.
More than fair.
Yes. Yes. Okay. Come on.
I did it myself.
This is taking a while to open, so somebody will need to read the question to me, please. What have we got for number 1? Oh. Well. See, it's going slow because I started an update and I thought it'd be finished by now. Here we go. An 80 kilogram physics student steps off a 200 kilogram rowboat at a speed of 2 onto a dock. How far away does the boat move? How fast does the boat move away from the dock? So he's 80, 200 and 2. So what happens here? This is 200 and the physics student is 80, and then when the student steps on here with 2 meters per second, the boat will move backwards. So we can use conservation of momentum. M1 U1 plus M2 U2. So both the boat and the student are not moving at the start. And then afterwards, afterwards the boat moves with V1 and the student moves with V2, which is 2 here. So we can, I think, easily solve this. Did you get 0.8?
yeah, no, I got
Mine.
0.2.
0.8 is the answer here. Minus 0.8 meters per second. So that's okay to start with. Right, let's see what 2 is. I'll go back to it. The 80-gram bullet and the 2-kilogram shotgun. Okay, so as you all know, classic physics question. So this is 2 kilograms, and then the bullet inside of it is 80 grams. Yeah, 0.08 kilograms. And then afterwards, just like with the boat, this will move backwards with V1, and the bullet will move forwards with 200. So once again, we have M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. And it's minus again because the gun goes backwards, so the gun will go backwards with 0.125 meters per second squared.
I got -8. I got my...
No, you have your fraction upside down.
Again.
No, wait, actually, maybe you're right, Mir. Sorry. No, maybe it was me that had the fraction backwards. Thank you, sorry, Mir. That's my fault. It was -8. I had it upside down. Okay. Number 3. A water hose is lying on the grass. The nozzle on the hose has a mass of 1 kilogram. A boy turns the water on and the water leaves the hose at a rate of 2 liters per minute. During the first second, how fast does the nozzle and hose recoil backwards if the water comes out at 2 meters per second? Okay, so what's happening here is you have the hose lying on the ground, and then during 1 second, when it's the first second when it's turned on, some water will fly out the front, and as you know from experience, this means the hose will move backwards. So I tell you that it's 2 liters per minute. A liter of water is a kilogram. So that means it's 2 kilograms per minute. Dividing by 60 gives me how much I have per second. So that's 0.0333 kilograms per second. Now, in the question I tell you that the nozzle and hose, this has a mass of 1 kilogram. So this is conservation momentum. The M1 is the hose, so that's 1, and initially it's at rest, and initially the water is at rest, so that's M2, 0. And then the water is opened, it's turned on, the water comes out, so you'll have M1 V1 plus M2, and then do I give you the V2? I do, it's 2. So the V1 would be, it'll just be minus 0.0666 meters per second. I know, I just made up these numbers. 6 centimeters per second? Maybe it's faster. Okay. Next one now. A male skater of mass 65 is moving towards a female skater of mass 50. She's getting towards him at 2, he's getting towards her at 4, and then they move off together. So it's 65 and 50. He is 65 kg, and then she is 50 kg, and he is moving towards her with 4. And she's moving towards him with 2. And then they move off together. And their combined mass would be 115 kilograms with a speed of, we'll just say, x or whatever, v then. So conservation momentum, m1 u1 plus m2 u2. Now last year, oh my goodness, like every single time nearly the students forgot about the minus here because she's gone to the left. So m1 u1 plus m2 u2, and then it's one combined mass.
How it's minus?
Which way is she going?
Left.
Left.
Yes.
That's right. Left is minus.
Okay.
Why?
Okay.
There is no two masses and speed.
Say again?
Why is there no two masses and two speed?
Here?
Yeah.
Because they move together.
Okay.
They're one then, one mass. So I get 160 equals 115 V.
1.39 or 1.4?
1.39 meters per second. Okay, so again, these questions are all pretty straightforward. Nothing too unusual. 5.
No, there's a part.
Oh, sorry. Oh, show that the collision is inelastic. Yeah. So the kinetic energy before the collision, that'll be, well, I'll just type it in on my calculator. Half v squared plus a half what is she? 50, is it? V squared. So before the collision, their energy is 620 joules, and then afterwards, a half 115 1.39 squared, and afterwards it is 111 joules.
We can
So-
also do like, the momentum before and the momentum after is not same.
Oh no, goodness, no,
No.
no, quite bad. The momentum is the same. That was the whole reason that's the whole point of this equation. This is the momentum before, and this is momentum afterwards, so it is the same. It's only the kinetic energy that isn't. So here we have it as inelastic, because it's because it loses kinetic energy. Yeah. Okay. Next now. The last one is also a classic physics problem. An 80-gram bullet is fired at 220 into a 1 kilogram block. So this one is number 6. Yeah.
No, 5.
Oh yeah, 5. So here's our bullet, and this is 80 grams, and its speed is 220 meters per second. And then there's a block here at rest, 1 kilogram. And then you have to be very clear about what's happening here. So what's happening is the bullet will move along and then collide with the block, and then the block will then
Would be open.
swing up.
I have one question.
Yep.
How is 0.8 and 80 grams?
This is 0.08 kilograms. That is 80 grams.
Oh, you are transferring.
Transferred, yeah. Okay. So I give you a little hint in the question. I tell you for the first part to use the conservation of momentum. So the momentum here before the collision with the block equals the momentum afterwards, after the collision with the block. So the momentum beforehand is m1 U1
M2
plus M2
U
U2, and afterwards their combined mass is 1.08 together, V. So 0.08 times 220 divided by 1.08. So the V is quite large.
15.8.
I got 16.29. Yeah, 16.3. Yeah. Then what happens is it swings up. And then what we say is the kinetic energy here equals the potential energy here. So yeah, a half v squared equals m g h. So here we get h equals 13.5 meters. Yeah. So even the last question wasn't that hard. I mean, not impossible.
Okay, from
Mhm.
how you got the 1.08?
The block plus the bullet together.
Like you plug the 0.8 with 1,
Yeah.
okay, then you multiply the 1.08 with 220, yes?
That's a 0.08. There's no 1 there. Here. So all I did, well, that's 0. Gone. So just take this underneath, and I got the V. And here, just take these two underneath, and I got the H.
No, I mean that the 16.3, that the 1.8,
This?
yes,
Yeah.
you multiply this 0.08 with 1, yes?
Add.
No, multiply.
No, listen to me,
Yes,
listen to me.
okay.
This 1.08
Yes.
was 1 plus point.
Oh, then how you got the 16.3?
Now, I've said that twice now, okay? So this is the third time I'm saying it, so you need to
Okay.
listen to me. I just said, take this
Yes,
under here.
yes,
So this plus this
yes.
divided by this. And this
Like
gives me
that.
the V.
Like this plus this, divide the 1.8.
Yes,
Okay.
yes, no, I've said that a few times, okay? So you need
No,
to listen to
but I
me.
did not understand.
Fine, but I think you listen more carefully, okay?
Yes.
Alright. Now, okay, well that's the end of the homework then, so we'll go on to the next lesson, okay? This is a typical common physics question, this collisions problem. I've seen, all of these are like exam questions, and they're good exam questions because they're not very difficult. The only way that they make this a little bit more difficult, no, they look for the angle here.
Wow.
Now that's not really that difficult because, for example, imagine you knew the length of the rope, let's just say it was 20 meters, for example. And how high did I say it raised? 16 meters, was it?
Yeah.
Well, let's just say it's 16 meters. Yeah. So it's gone up in the air 16 meters, right? So therefore, how much is this piece from here to here? 4. And then how much is this piece from here to here?
4.
No? We had a long discussion about it last week. No!
Sine.
No!
How?
Yes.
But I don't remember the method. I don't.
How quickly we forget. So,
Yeah, they're all the same.
yes, indeed. So, you can use Pythagoras to get this side. And then once you have Pythagoras, you can do theta equals tan inverse 19.6 over 4. And then you got the angle. So, you know, this is how they make it a little bit more difficult in the exam, but if you just take your time and remember the basics, it's not really that much more difficult.
They give you the height?
No, we found this.
Okay.
They will need to give you this. Yeah, yeah. I didn't give it to you in the question because you didn't need to know it. You only need to know it if you want the angle. It's okay? Alright. Okay, let's close this and start the next lesson then.